The Big Bang Theory. We've all heard of it, but most of us don't know a lot about it. In the beginning, physicists thought the universe was static, meaning it has always been the way it is. This was until Georges Lemaitre put forward his Big Bang Theory, which he called the primeval atom. He came up with this by connecting Edwin Hubble's realization that galaxies are moving farther and farther apart from each other, to Einstein's theory of relativity, which gave us a better idea about how gravity works. He figured that if things are moving further away from each other, then at some point, they must have been much, much closer together. Cosmic background radiation was discovered in 1964 by two researchers. This radiation was emitted 13.7 billion years ago, at the beginning of the observable universe. The researchers found that the radiation was coming from all directions, and there were no spots without radiation. This strongly suggests the Big Bang Theory is true. When people try to visualize the Big Bang Theory, they usually think of an explosion, which it was not. The universe actually expanded or stretched out without an explosion in a period called inflation. The observable universe started off in a very small point in space, which we called a singularity. We have no idea what's going on at that point. Our concept of space and time make no sense, and so it begins. The observable universe expanded into the entire universe into a sphere about a foot in diameter. It was so dense that the temperatures were unbelievably high. In the Quark Era, matter beat antimatter and gluons created pairs of quarks, and those quarks found other quarks to contact and then break into more gluons. Immediately after, the forces of the universe finally became separate. These forces are the strong nuclear force, the electromagnetic force, the weak nuclear force, and gravity. The strong nuclear force holds the nucleus of an atom together. The weak nuclear force causes the beta decay of atoms. The electromagnetic force causes static electricity and makes magnets do the things they do. And gravity, well, you know what gravity does. The universe has now grown to 1 billion kilometers in diameter, so the temperature becomes cool enough that quarks stay. Quarks can now come together and form hadrons. Examples of hadrons include protons and neutrons. Now, most neutrons decay into protons and allow for the first atom to arise, the hydrogen atom. The universe is now 100 billion kilometers in diameter, and it is around 10 billion degrees Celsius. After this, the universe starts cooling quickly. Hadrons and electrons create atoms that are electrically neutral. There are no stars yet, and the hydrogen gas doesn't allow for light to pass through anyway. The hydrogen gas is compressed until it forms stars and galaxies. The radiation from stars and galaxies dissolve the hydrogen gas into plasma that is still spread throughout the universe, allowing visible light to be seen. Not much has changed from then to now. That is more or less the universe we live in today. There are many theories as to what happened before the singularity, but none of them can be backed up with any evidence. But we don't have to worry about that too much. We can just enjoy the fact that these things happened, and that we are lucky enough to experience the result. Thank you.